to Did You Ever Wonder? I'm your host, Susan Gill.
I'm Martin Bell.
And I'm Vanessa Bell.
Today's topic is the ocean.
And the ocean is something that we're all very familiar with here in Newfoundland. We all live by it, and a lot of Newfoundlanders make their living from it. I'm sure this is going to be a really interesting show. We speak to Dr. John Lean from the Whale Research Group of Memorial University. And we also went to the Marine Dynamics Institute and learned a lot of interesting things about waves.
We are now going to speak to Dr. John Lean to tell us a little bit about whales.
Sort of ran around and tried to save one animal.
Dr. John Lean is the head of the Whale Research Group here in St. John's. We asked him to describe the average life cycle of a whale.
We always talk about whales almost, and people will say whales are an endangered species. Well, whales aren't a species, they're a whole group of species, and they're very different. They go from tiny, tiny animals about 1 meter long to animals that are 105 foot long and weigh 150 tons. There's just tremendous diversity in this group of animals. So maybe it's best to concentrate on one animal, and because it's the most common whale in Newfoundland, the humpback is a good one. Humpbacks are born in the Caribbean. The pregnancy lasts about 11 months, and the calf is born down there. It follows its mother up, probably being sucked along in her wake. It doesn't have to swim all the way back to Newfoundland, but sort of is pulled to Newfoundland by the wake of the mother. The calf will suckle on the mother for about 7 months. Whales are mammals. They produce milk, and they rear their young by producing milk. At that point, he'll probably be in Newfoundland at 7 months of age. There'll be a lot of food around, like krill and capelin, young herring, squid, and so on, and the young animal will start to feed. While it is young, it seems to gain attention from a number of adults. There will be other adult animals that seem to look after it, watch out for it, and so on. When the mother dives deep, the baby doesn't seem to have the capacity to do that, so it will often hang around at the surface, and the other adult will sort of stay up there with it. In Newfoundland, humpbacks are subject to attack by killer whales, and about half of all the humpbacks in Newfoundland have killer whale scars on their tails. So for a baby, there's a fair threat from killer whales. Another threat to a young humpback would be the nets of fishermen. These guys don't know about nets. Nets aren't something natural to their environment. It's something new in the past 100 years or so. So they haven't evolved to sort of pay attention to those and detect them. So they have some problems. And the young fellas seem to be risk takers. They don't care anyway, and they go swimming around. And usually when humpback whales are caught in nets, it's one of the younger animals rather than older animals. The older animals are sort of streetwise and know to stay out of the way of nets. The young whale will stay in Newfoundland fishing pretty much all summer. He starts fishing. As soon as he hits Newfoundland, will then migrate more or less northward, may end up in Labrador. And then about October, starts to get full, has put on a lot of weight, has gotten very fat, will then start moving southward and over time migrate down to the Caribbean. He spends all the winter in the Caribbean, doesn't eat a bite, and sort of spends this winter socializing, doing all kinds of things like that. And then that cycle turns around next spring, he swims back to Newfoundland. The maturity in humpbacks probably doesn't come until they're about 30 foot long, and this is maybe at 5 years of age. After a female is mature, she'll probably have a baby every 3 years or so, and maybe have a productive lifespan of 25 years. So they don't have great growth potential as a population.
Is it true that whales have a lot of human characteristics?
Well, people like whales, and when we like something, we tend to think of them as like ourselves. And so what generally people believe about whales is they communicate a lot, they're very intelligent, they're very altruistic, they help each other. And there are some behaviors in whales that tend to sort of go along with that. One thing that most people have heard about is singing in humpbacks, which is a really remarkable phenomenon. The humpbacks that are here in Newfoundland are relatively silent. When they vocalize here, they sound like pigs. They grunt and they fart and things like this. It's not very interesting. But when they migrate south, they come to the breeding grounds. They sing these long, complicated songs. These last from 5 to 20 minutes in length. And the curious thing about them is that on a given year, every whale sings the same song. So that every male humpback, it's the males that sing, every male humpback sings this long, complicated song. Well, birds sing fairly long, complicated songs, but the interesting thing about humpbacks is the next year they come to the breeding grounds, they all sing the same song, but it's a different song. So in that year, they've had to learn a new song. Whales do what we call as echolocation. Echolocation is where I produce a sound and then listen for the echo back of that same sound. Humans can do this in a rudimentary sense. If I tap something, I can hear echoes off the wall and so on. Well, whales can do this in a very precise way. They can generate sounds inside their head. They can direct these in a narrow beam so they focus the sound, and they can hit a target and then have that sound come back, and even decide on how big a fish is or what species of fish it is and so on by the nature of the echo back. So it's a very sophisticated sonar system, and the toothed whales use this as the way they find bait and the way they find obstacles and so on.
How do you go about accurately identifying and counting whales?
Whales are very difficult to study. Most of the time, all you see is the very tip of their back or their tail. And that doesn't give you a lot to go on when you're trying to, and that happens very quickly, so it doesn't give you much to go on when you're trying to decide on species. Most of the questions that we want to ask about whales require information about where the animal's been and where it spends its time and so on, who it hangs out with. And a few years ago, with humpback whales, a group of scientists discovered that each of their tails were like fingerprints. If you took a picture of a humpback fluke, in fact, that identified the individual. And in Newfoundland, we've been taking pictures of humpback flukes now for about 15 years. So most of our population, probably 80% of the humpbacks in Newfoundland, are individually identified. We know them as Tom or Sally or Mike or Pete. And that gives us tremendous possibilities as far as studying them. We can say, well, we know the animal moves from here in Newfoundland to there in Labrador and then to the Caribbean. We know it spends its time with these individuals. We know it has a calf this year but doesn't in the following year, so we can get birth intervals. In some cases, we've been able to tell how long the animal lives because we had a photograph of it as a calf and then we found it dead and we identified it as an adult. These individual photographic techniques also give you a possibility for censusing a population. It's always been extremely difficult to count whales. A whale comes up here, you say that's one whale. And then another sighting is over here. Is that the same whale or is that a different whale? You know, if you just are looking at backs, it's very difficult to say if each of these surface scenes is the same animal or several animals. When you use photographically identified whales and wait to count when he puts his tail up, for instance, you know that's one whale, and if another tail comes up here and it's the same whale, that's still one whale, or if it's a different tail, that's two whales, and so on. So you can count very accurately. And you can estimate total population size based on how many photographs you have and how many are in the catalog that match these photographs. So you can get a ratio of that gives you an estimate of the total population. The humpbacks in Newfoundland are the most individually tagged population of wildlife in the world, apart from a few things like, you know, maybe some exotic wildlife like
Well,
pandas
that was very interesting. Amazing how much you can learn about whales. I have with me here a piece of whale baleen, which is what the whale uses to eat. He filters the plankton.
Through the little hairy things.
Yeah, through these little bits of, well, it looks like hair, but it's much coarser than that. And baleen is really a much larger piece, and this is just a shaving of it. Martin?
Today we spoke with Derek Yetman from the Marine Dynamics Institute about ships and oil rigs in relation to waves.
The Institute for Marine Dynamics is a $55 million facility located on Memorial University's campus. It is a Canadian Crown corporation that specializes in testing designs of ships and oil rigs in any ocean conditions imaginable. Scale models are built according to the exact specifications and then tested in either the wave tank or the ice tank. Computers monitor and record every response made by the models and then evaluate the results. Norman Jeffries, the director of the Institute for Marine Dynamics, describes the Institute's function.
We have the facilities to do a couple of very important jobs. These big laboratories are here so that we can check whether or not our understanding of the physics of ships in the oceans and offshore structures is correct, and whether or not what we predict that they will do in various circumstances is correct, so that we're safe and efficient. Often you can do this with smaller models. It's a lot less expensive than using a full-scale oil rig or ship. So these laboratories do make use of smaller models to get you some data to figure out whether or not your mathematics is right and your physics is right. But in the end, our people also have to go to sea and make the measurements on full-scale ships to make sure that even the model results can be scaled properly. There are very few establishments as good as this in the rest of the world. We have a unique collection of people who are internationally expert in a few key areas. Ice effects on ships and operations in the north, for example. And we have unique research facilities in that our refrigerated towing tank, or as our taxi drivers call it, the ice tank, is the best in the world for its purpose. And very shortly we're going to commission perhaps the best model ocean in the world. Best model in the ocean in that it will have 3 wave systems interfering simultaneously under digital computer control in the middle of our tank.
Gary Fudge is in charge of overseeing the construction and development of the new wave tank.
The project started approximately 2.5 years ago, and with annual expenditures up to the order of $3.5 million, totally we expect of the total amount of $10.5 million that there will be about $5 million actually put into the local economy here in terms of mill rights, direct buyouts, those sorts of things. The project itself is now slated for completion in January of 1990 of this year. The entire objective of the basin, which is now called the Offshore Engineering and Seakeeping Basin, is to permit the testing of offshore structures, such as semi-submersibles, gravity-based structures. We can also do ship maneuvering in this basin as well. The entire concept is to model realistically the sea states that one would find, for instance, on the Grand Banks here in Newfoundland. This particular wave machine will be capable of modeling 3-dimensional as well as 2-dimensional sea states, and once complete will be really a state-of-the-art facility that will be the most modern of its type in the world today.
One of the most interesting facilities at the Institute for Marine Dynamics is the refrigerated towing tank, better known as the ice tank. This tank allows testing on models to see how they will react to icy conditions. The ice thickness and strength can be varied depending on the model and the real-life conditions the tank is recreating. Bruce Parsons explains the technology involved.
Well, we're standing here on a large carriage. It's about 80 tons. It rides on 2 rails down this tank, which are 12 meters apart. Attached to the carriage, we have a tow post. The tow post is what we use for attaching to the ship. And on the ship, we usually put a variety of instrumentation load cells, accelerometers, displacement transducers. All of this is connected back into the computer on the main bridge of the carriage, and with all of this we can collect the overall load on the ship. We can collect the information on the propeller thrust and torque, and on the ship motions. We have anything from straight accelerometers and load cells to LVDTs, linear variable differential transformers, and all of this is hooked into a small computer and can in sequence be hooked to our large mainframe computer. So it's a standard engineering instrumentation. We can make a 40 millimeter sheet once a day. The thickest sheet we've had here is about 130 millimeters, and that takes about 2 days to freeze, and then what we have to do is temper it. In other words, we have to let it sit in slightly warmer temperatures so that the strength of the ice comes down to the right strength required for your scaling of your model. So that test took actually a week to get ready. And then, of course, the test itself is over in several hours. We generally work in the range of 1/10 to 1/15, and we're generally trying to scale ice that in the field would be about 1 meter to 2 meters to 2.5 meters thick. What we generally use is the type of ice that was developed at NRC in Ottawa. It's called EGADS ice. That's ethylene glycol, aliphatic detergent, and sugar. The glycol we use in the ice is frozen into the ice when the ice is formed, and then, as I mentioned earlier, we temper the ice, and during the tempering, the glycol, which is an antifreeze, melts the ice from inside where it's trapped, and this brings down the strength of the ice to the strength required, and that's the real trick in the scaling. It's easy to get the ice, say, 1/10 as thick if you have a 1/10 model, but to get it 1/10 as strong is the real hard thing. So that's what the mixture of what do you call them? Dopants are used for.
As Bruce explains, it certainly is beneficial for companies designing ships to test them here first.
It's a lot cheaper to test it here than it is to build the full-scale icebreaker, which can range anywhere from $20 million to $500 million for a large icebreaker. And a test program here is a small fraction of that. We can then tell them if the propeller and propulsion units that they plan to install are going to be adequate for their mission. For example, if you're trying to get through the Northwest Passage in February and you know the ice is 2 meters thick, and you decide you're only going to put in 15,000 horsepower, you may find out, we can test it here, and we can tell you whether or not you're actually going to be able to go through 2 meter ice. So it's not just a question of whether or not the ship is going to consume more power and more fuel. It's going to be a question of whether it can actually do what it's supposed to do, and that's where we can tell. Another interesting thing about this tank is we have underwater video, which shows you very nicely the flow of the broken ice around the hull. The other tanks have windows either in the side or in the bottom, and although you can see through the window what's happening, you get a distorted view because of the nature of looking through water. So this underwater video system travels with the hull. You can zoom in on the propellers or the bow or whatever your area of interest is. We spend a lot of money on that and the filtration system to keep the water clear.
The emphasis placed on recreating every meticulous detail results in a very high accuracy rate with these tests.
Well, the tests themselves are accurate. The predictions, however, are open to some interpretation. There's still not total agreement in the community how to scale your results to full scale, but we feel we can get within 10% of predicting what the loads, the propulsion requirements, propeller requirements would be on an icebreaker that we test in this tank.
Dr. John Lean, who we spoke to a little earlier in the program, works with the Whale Research Group of Memorial University. We asked Dr. Lean to explain something about what the Whale Research Group does.
The Whale Research Group started in, I guess, 1978, and it was organized by people who came together because fishermen were having trouble with whales. So really the impulse for organizing the group was to help fishermen with a problem, and I guess to help whales that were having a problem with fishermen, and to try and solve this applied sort of difficulty. So one of the things that's always been a focus of the group has been a service aspect where we go out and help fishermen that catch whales so they can minimize their downtime and their gear damage. But the major focus of the group is a scientific one, and so we try and study and understand these animals. And so I happen to be an animal behaviorist. I'm interested in the behavior of the animals. There are other people that work here that would be chemists, they would be engineers, they would be mathematicians and so on, biologists, who are interested in different aspects of the biology of the animals. Well, the problem of humpbacks hitting fishermen's nets started to be, people started noticing it about 15 years ago. And the problem coincided with an increase in effort in the inshore fishery, so there were more nets in the water. But more dramatically, during that period in the late 70s, the capelin just disappeared. There were very few capelin. And humpbacks normally are inshore, but they're also offshore in the Grand Banks. And their favorite food is immature capelin. They'll take that over and against mature capelin or anything. With no capelin offshore, more humpbacks came inshore, and they were right in the areas where the inshore fishermen work. So what happened with all these nets in the water, with all the humpbacks inshore, boy oh boy, the fishermen were having a terrible problem. You know, the whales time after time would collide with nets. And it's very expensive for the fishermen. These guys aren't rich. They need these nets to earn their living, and they have a very short period in which to earn complete a voyage. So when a whale hits a net like a cod trap, it's very serious for the fishermen. And it can be very serious for the whales. Prior to the establishment of the release program, about 50% of the humpbacks that got caught in nets or hit nets died. The mortality was 50%. In some years, we estimate that maybe up to 30 animals were dying, which was of great concern to people that were concerned about that stock of animals. This was new mortality, which perhaps that population couldn't stand. So in 1979, we organized a program to try to take the major cost out of this collision problem. And what we did was develop techniques to release the animals from fishing gear without hurting the fishing gear. And so now what happens, the program's operated for 10 years, and the Newfoundland Department of Fisheries and Fisheries and Oceans Canada have supported it during that period, along with the university. When a fisherman has a whale caught in his net, there's a toll-free number that he can call, and we'll send a crew out to help him take the whale out. The sooner they call, the better it is. Both for the damage to their gear and probably for the whale mortality. If you leave a whale in fishing gear so long that he eventually decides to put his strength against the gear, he'll kill himself, but he'll wreck your gear in that process, for sure. These are very strong animals. An average humpback is going to weigh 20, 30 tons, and when you put that force against nets and stuff, it's bound to wreck them. If, on the other hand, you take the animal out without scaring it before he's really cut loose against the gear, oftentimes the gear is fishing after you've taken the whale out. There's no reason to have great damage to the gear in most entrapments. So if a fisherman requests, we'll go out, and there's a crew of fishermen that work with the Whale Research Group now, and they're the ones that go out and help the fishermen. The first thing we do is try and understand the accident from the fisherman's point of view. Is this his best berth? Does he have other traps to haul? How many nets does he have in? Does he want to get the whale out fast? Does he want to go slow and prevent any damage to the gear and so on? We try and understand all of that. We'll then go with the fisherman and take our boat out to the whale. Then we have to get the whale used to us and our boat to work efficiently. On taking the whale out of the gear, we essentially have to be right on top of the whale, and we don't want to scare it. If he doesn't cooperate with us, they're so powerful you can't do anything. So you don't want to scare it. You want to get him used to your tools and your boat and the sounds you're going to make. While we're doing this, we're also getting the fishermen used to the whale. These are big wild animals, and there's no reason not to be afraid of them. And so you have to overcome your fear of them, and you have to get the fishermen used to being that close to a whale. The fisherman is critical in the operation because he understands the fishing gear better than anyone. He knows that this side has a patch in it and that side has a different colored rope in it, and we don't know that. We know what fishing gear is in general like, but we don't know this specific piece of gear, and that's where the fisherman can be very helpful. So we'll get the fishermen used to the whale, and we'll get the whale used to us, and we'll be in our boat right on top of it. Now the whale wants to dive all the time, and that will take you forever to untangle it. So the next thing you want to do is get the whale so it's right up beside your boat, and you essentially hold it at the surface. Now if that whale wants to go down, it can go down. But it turns out that humpbacks especially are essentially sissies. And as they're caught, oftentimes there's a piece of line that just goes in a little cut, and that's the piece of line we'll hold. And the whale will very quickly learn that if it tries to go down, that cut hurts, so it won't try. And so eventually, with a very small piece of line, you'll be able to keep the control of the whale, and you'll keep him at the surface. Now, if you scare him or something, all the rules like that go, and he'll dive, and you can't hold him. But if you're very cautious and you just work this one small bit of line that hurts the whale, he'll quickly behave so that it doesn't hurt him, and he'll stay at the surface. And then you can see exactly how he's caught, and you can unwrap it here, and you can sort of scare him that way and unwrap it over on the other side. And rather than take out a knife and just cut it all to bits, you can unwrap it and minimize damage to the gear. Over the 10 years, the first year the whale program was in service in Newfoundland, mortality of humpbacks was 30%. Prior to it starting, it was 50%, so that was some improvement. Over the 10 years now, we're down to about 5% mortality. And that's important even to fishermen, because a dead whale in a net is a major disaster. That's where you lose thousands and thousands of dollars in gear. If the whale's vented its fury against the gear and eventually killed itself, the gear is severely damaged. But if we take it out, I would guess over half the time the gear's fishing when we leave. So the costs of an accident have come down rather dramatically, as has the mortality of the whales that are caught.
Take us back a bit more.
Well, that's all for this week. We hope to see you next week. Bye.
This is Carl and Terry. Like many youngsters in the CHAMP program, they lost their limbs in accidents. That's why CHAMP say,
whatever game you play, play safe.
Play safe.
You're viewing Avalon Cablevision's Channel 9.